In this video, we're going to see how to find or conduct a hypothesis test of a population proportion. After doing a lot of playing around, I've realized that it's a little tricky to use Statistics Kingdom to do that. So I'm going to show you all how to do it using StatPower. Of course, you can use Megastat if you have that. So your statistics instructor claims that 60% of the students who take her elementary statistics class go through life feeling more enriched. For some reason that she can't quite figure out, most people don't believe her. You decide to check this out on your own. You randomly survey 64 of her past elementary statistics students and find that 34 feel more enriched as a result of her class. Now, what do you think? Okay, so let's first write down our hypotheses. So our H sub 0, our H naught or null hypothesis, we're talking about some percentage of stuff, in this case students. So that's a P, right? That's a proportion. So this is indeed a proportion that we're looking at that we want to test. And we're looking to see if our P is 60. Well, I'm sorry, we're not looking to see if it is 60%. We'll see what our alternative hypothesis is in a second. But the default is that our proportion is actually equal to 0.60. So then our alternative hypothesis, HA, they don't really give us a ton of guidance here. I think we could say not equal to, since they don't really say one way or the other. But it seems to me the implication in this problem is that it's less than. People think it's less than. So maybe we use less than, and this would be a left-tailed test. Okay, so for our test, we need to also notice our sample data. So N was 64. And so our P hat or P prime is 34 out of 64. And I already calculated that's about 0.5313. So we'll see what we have to put into StatPower to get it to work. And then I'll show you like some ways that you can make Stats Kingdom work and why it's a little bit annoying. Okay, so StatPowers. So we're going to click on Analysis and then Quantitative One Sample. And we're going to ignore all of this and scroll down until we see hypothesis testing. Oh, and that's right, we weren't given a significance level either. So let's use the most common one, which is alpha equal to 0.05. Okay. So we're going to keep this at 0.05, and we're testing the proportion, test for a proportion. And so this pi, he's using pi instead of p, but we're going to change this to 0.6 or 0.60, and then change this to less than. And I'm going to leave this alone right now. We'll see if we want to do something with that. So now I'm going to click this Enter Summary Stats tab. My number of successes was 34. 34 said yes, and N was 64. And enter, and here are the values. So p-value right here. So 0.1307, blah, blah, blah. So let's go back. And our p-value was 0.130. I think it actually, if we rounded, was it to 7 or 8? It would be to 8. So that's like 13%. And that's more than 5%, which is greater than alpha equal to 0.05, our significance level. So that means we do not reject the null hypothesis, or H sub 0. And our conclusion then could be maybe something along the lines of, at a 5% significance level, there is not sufficient there we go, evidence to conclude that the proportion of students who feel enriched is less than 0.6, or less than 60% maybe, since that's how it was given in the problem. So that is supporting what the teacher originally said. So let's look at what is this thing? Statistics Kingdom. So if we go to the home page and go and look at all these like test calculators and scroll down, we can eventually find this one sample proportion test, number 14. And if we put everything in that we were given and then calculate z-test, because that's what we're supposed to be doing, our book is expecting us to use a normal approximation. And then scroll down. It comes up with the same conclusion, but the p-value is a little different. So this is 0.15, blah, blah, blah. So about 0.16. We got about 0.13. So that can be maybe different enough to cause some problems with our homework. And if we look back at StatPowers, look, here is that p-value that Statistics Kingdom is finding. So it's finding a binomial p-value. So this is more exact. We're actually approximating our p-value using the normal distribution. And so in some ways you could say, well, this is actually better, but that's not what's going to be counted correct in our homework, I don't think. I say I don't think because maybe it's set to like accept a really large range of values. So I did find that if we go to the z-test, one sample z-test, and use all of this same stuff, but use for the, for the x bar, so we're thinking of this as a mean, so our x bar is our p hat, so that 34 over 64. And then our mu is 0.6, the p, and then sample size 64. So then this right here is not coming from any formula that we've really used. This is equal to the square root of PQ. So that would be the square root of 0.6 times 0.4. And basically it's just, it makes the math work out. So if we do calculate test, then we get pretty much the same p-value. So there's a way to make it work. I don't know, it seems a little tricky to me, so it's probably better to use StatPower to test a proportion.